All right, then we have worksheet 1. We started talking about this in class a bit. The scientific base unit for charge is coulombs. See, 1 proton has a charge of positive 1 E or positive 1.6 times 10 to the minus 19th coulombs. 1 electron has negative 1 E and negative 1.6 times 10 to the minus 19th coulombs. What's the charge of an oxygen nucleus in units of this? Well, oxygen is 8 protons, 8 neutrons, and 8 electrons. All right? That's what oxygen is. So that would be positive 8E, 0E, and negative 8E charge units. So the net charge of any atom is 0. Well, the nucleus is just the protons, right? So it's 8 protons equals a charge of positive 8 fundamental charge units. 8 positive 8E. Or 8 protons equals 8 times positive 1.6 times 10 to the negative 19th coulombs. All right, let me see if I have a calculator handy here. Just so I don't foolishly make any math mistakes. So we've got 8 times, let me show my calculator how you type these in really quick. I like to use that double E button. All right, 8 times 1.6 double E negative 19. All right, and that gives us, well, it gave me it in terms to the negative 18th, but I'm going to write it as 12.8 times 10 to the negative 19th coulombs. All right, because I just want to see that exponent. Yes, that would be 1.28 times 10 to the negative 18th coulombs, but I'm going to write it like that. Sometimes we do that when we're talking about charge and such. Number 2, let's say I touched the electroscope to the Van de Graaff generator and 2 billion electrons were transferred to the electroscope. The charge in elementary charge units. So 2 billion is 2 times 10 to the 9th electrons. That would be a charge of negative 2 times 10 to the negative 9th fundamental charge units. I should make these E's a little more script looking, right? That's kind of the deal with that. It's not just a lowercase e, it's kind of like the script E. Now, what about in coulombs? Well, that would be 2 times 10 to the 9th times negative 1.6 times 10 to the negative 19th coulombs. Because this would be the number of electrons right here. Each electron carries that much charge. So we've got 2 double E button number 9 times negative 1.6. Oops. Let's hit not 1. Oh no. 1.6. Double E button negative 19 is negative 3.2 times 10 to the negative 10th coulombs. Now, when we're talking about really big and really small numbers, we don't like to use scientific notation, right? We like to use these prefixes. And you have lots of experience with these. Prefixes are how you talk about phone memory, computer speeds, picture size, camera size, all kinds of different things we use prefixes in that maybe you don't think about. Let's look at a few of these examples here. Write the following decimal values in scientific notation and the nearest nanocoulomb, picocoulomb, or microcoulomb. So let's look at this one first. Scientific notation. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So it would be 3.1 times 10 to the negative 9th coulomb. 10 to the negative 9th. Now, what these prefixes are, these symbols, like tera, for instance, terabyte. A terabyte is 1 times 10 to the 12th bytes. So the t replaces the exponent and the power in the equation. So 10 to the negative 9th is nano. So that would be 3.1. Then we replace the scientific notation with a lowercase n, nanocoulombs, and that's the pronunciation, nanocoulombs. This one here, 1, 2, 3, 4, 5. So it's 5.6 times 10 to the negative 5th coulombs. However, there's no times 10 to the negative 5th. So I want to make it 10 to the negative 6. Well, I would have to go one more here, right? If I went one more, so I could make it, we'll go one more here. I would go 56 times 10 to the negative 6 coulombs. Then I can write it as 56 microcoulombs. So there's a little bit of tomfoolery going on here, right? 1, 2, 3, 4, 5. That's where we should stop. That would put me at negative 5, but I want to go to negative 6. So it's going to be 56 times 10 to the negative 6, or 56 microcoulombs. Let's do this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, is that one of the good numbers? Yeah, pico. Great. So it's 2.5 times 10 to the negative 12th coulombs, which would be 2.5 picocoulombs. Very common thing to do in engineering science, to convert from scientific notation to something that we can say easier. Let's do this one. 1, 2, 3, 4. Uh-oh. That's not even close. 4. That's not on there. I could go 3, so 0.934 millicoulombs, but I'm going to go instead, we don't do that. We like to go to bigger numbers. 4, 5, 6. So I go 934 times 10 to the negative 6th coulombs equals 934 microcoulombs. And the final one, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's pretty straightforward. 7.31 times 10 to the negative 9th coulombs, or 7.31 nanocoulombs. Not bad, not bad. Let's see what we got next. We're gonna get up to this point, and then we're gonna stop this video there, and then maybe shoot another video about Coulomb's law. What is the least amount of charge in coulombs that something can have? What is the second least amount of charge in coulombs that something can have? Use an illustration. So, if I had a hydrogen nucleus, it'd be +1 proton, right? Can I split the proton in half? Nope. I mean, you could, but then you get a nuclear reaction. So the smallest thing that something can have is either, same thing with an electron, right? You have an electron that's -1, right? Smallest charge possible is 1.6 times 10 to the minus 19th coulombs. Now, the next smallest charge possible would be 2 protons put together, +1, +1, right? That would be next smallest would be 2 times this, would be 3.2 times 10 to the negative 19th coulombs. All right, the next one would be 3 times this, which is like 4.8 times 10 to the negative 19th coulombs. So you can't just have any charge. It's got to be an integer value of 1.6 times 10 to the minus 19th. This concept is known as quantization. Quantization. If something's quantized, it can't be any value. It has to be an integer value of some set value. This is where the phrase quantum mechanics comes from. The charge can only be specific quantities that are integer values of 1.6 times 10 to the minus 19th coulombs. It could be, n times, you could think of it, n times 1.6 times 10 to the minus 19th coulombs, where n is an integer value. All right, it's quantized. It can only be specific quantities. Turns out most things in life are quantized if you look down small enough. Mass, speed, energy. At the end of the day, they're all quantized, which is really kind of a strange thing. So things can't behave any way. They have to behave in very specific ways. And when you get down to the microscopic level, they can behave very strange ways. The whole Ant-Man thing in the MCU, quantum, whatever they call it, you went to the quantum realm, Well, there's some science to that. There always is science to good science fiction.